Okay, now the section number 8.4. Confidence interval again. For one unknown population mean again. But look at this. You know, even before, the section title was confidence interval for one population mean when sigma was known. Please make sure. Please go back to the previous page, the previous sections. We assumed we knew the sigma, but now it's not. I told you, in chapter 7, we assumed we knew the unknown population mean, and we knew unknown population standard deviation, the sigma. But now in chapter 8, we estimate unknown population mean, the mu. But very first, we assumed we knew the sigma. Still, we assumed we knew unknown sigma. But now, we break the assumptions is one by one. So now I can say we don't know what is the mu, what is the population mean. So we trying to make the confidence interval estimation for the mu, unknown population mean. And also, we don't know what is the sigma. So please look at this picture, this formula. It is the old one. There was a sigma. We plug the sigma here. But now, we don't know what is a sigma. What can I do? We don't know something. What we did in statistics? Guess. Estimate. Why not? What is the good guess? What is the good estimate for unknown, now, population standard deviation? Think about that. Just a second. Let me ask you another way. Who was this? X bar. Who was it? X bar is a sample mean. And point estimate. The sample mean X bar is on point estimate. For whom? Unknown population mean, mu. Can you remember? Let me say again. Sample mean is a point estimate for unknown population mean. That's good, right? What do we want to do? We want to estimate the population standard deviation. How do you think? Who will be a good point to estimate for the population standard deviation? Still no idea? Let me try again. Unknown population mean was estimated with the sample mean. Now, we want to estimate unknown population standard deviation. The question was, then who is the good estimate for the population standard deviation? Thank you. Who? The sample standard deviation. See, we estimated population mean with the sample mean. Now we can estimate the population standard deviation using what? The sample standard deviation. Please look at me. I'm short. How about my father? Can you estimate my father's height? From whom? You can guess my father's height from me. What do you expect? Is my father is a 6 feet? How about my mother? My sisters? Yeah. I told you, I'm not the outlier in my family. I'm in the box, in the middle, right? Yeah. It is easy. Yeah. For the first time, it's very confused, right? It's very stupid things, right? But always we estimate something in the population from the sample. Please remember. Okay. So now, sigma was unknown. We keep all the others. Sample mean, point estimate. Sample size here. Now here, we plugged small s. Can you remember the symbol small s in chapter 3? It was the sample standard deviation. Unfortunately, we are not going to use the z anymore. We used the z-score when we assumed we knew the sigma. The z-score and the sigma, they are friends. It's not friends, sample standard deviation. Now, we are going to take another score. T. Be careful. We are going to discuss T distribution, not the standard normal distribution. So from now on, when we assumed we don't know the sigma, and we are going to use the S, then we are going to take another score named the T-score from what kind of table? T-table. We took the Z-score from the Z-table. We are going to take the T-score from the T-table. Does it make sense? Right? So let me introduce to you what is the T distribution. It is the T distribution. Can you remember what was the shape of the standard normal distribution? Standard normal distribution was bell-shaped, symmetrical. How much was the mean? Who was the mean? Mean was a 0. It's almost the same thing. It is almost the same thing. So on this picture, the green curve is the standard normal distribution. But the T distribution is a little bit, it's shorter, like me. But even the T distribution make the 100%, the whole area. So because of that, at the tails is a little bit thicker. In the middle is a shorter, but the tails, the left end, right end is a little bit thicker. Does it make sense, right? It's almost the same. The T distribution looks like the standard normal distribution, but a little bit different. Do you know why? Yeah, it is a T-table. Yeah, we are going to use the T-table because the T distribution was from the Z, from the standard normal distribution. So let me introduce you who made the T distribution. You can Google William Gossett introduced the T distribution about 100 years ago. He was born in 1876, and died in 1937. About 100 years ago, he suggested the T distribution from the standard normal distribution. I Googled, who is this? The William C. Gossett. What he said? The Wikipedia? He was head blower of what? Guinness. Do you know what is Guinness? Did you try? Do you like it? Do you like it? I hate it. It's very strong. Dark beer. You love it. Oh my God. Yeah, even you never ever tried Guinness. Yeah, tonight. Just a second. How old are you? 24. Oh, you are enough. Try the Guinness. Yeah, at least 21. Yeah. I hate it. Yeah. It's very strong. Dark beer. Okay. Let me see. Probably he majored, I remember he majored in math and chemistry and statistics. What was his job? How do you think?
Scientist.
Say again?
Mathematics, a scientist.
The scientist for what? In the company. For beer. You can read the Wikipedia. Yeah, he majored in chemistry also. It's not only math, not only statistics, but chemistry. How do you think? What do you expect? What was his job? I think his job was the quality control, something, right? As the better taste. The better taste means is a stronger. The stronger beer, the stronger, darker and darker, right? The strong taste. If you want to test the taste, what we have to do? Try. Drink the beer. I think it is another good job. 9 to 5, drink. Again, drink. Drink. Sampled. What happened in the afternoon? Drunken? Sleepy? Right? Yeah. Just a second. Can you remember the central limit theorem? You know, in chapter 7, we saw a theorem named the central limit theorem, CLT. By the CLT, we had sampling distribution for the sample mean, which was the normal distribution, with the mean, the standard deviation. Still, we use the mean, the standard deviation, right? Before, in chapter 8, we assumed we knew the sigma, and we used the standard error, the standard deviation of the sample mean, using the sigma, right? So still, we use the central limit theorem. Do you remember what was the condition to apply the central limit theorem? Please go back to the chapter for the central limit theorem. It said we need more sample size. Just before we discussed the sample size, do you remember that? We need more to make less error. Absolutely, always we need more sample size. How about his case? Drink. Guinness, the dark beer. For me, even a couple of cups of Guinness, after that I drunk it, I sleep, right? I think he couldn't make enough sample size. What does that mean? he couldn't use the normal distribution. He needed another distribution. It was the t distribution. But it was from the standard normal distribution. Because of that, the t distribution looks like the normal distribution, the bell-shaped, symmetrical, mean equals 0. Okay? So now we assumed we don't know what is the sigma. So we are going to use the t distribution, the t-score, instead of the z-score. So now please look at this. It's almost the same. It is almost the same. But here's a t-score. And here's the s. That is the only difference. That is the only difference one. Okay? So let me look at the example. Please read carefully. But kindly, here's the sample mean, the point estimate, the very first one. Here is a sample standard deviation, S. Let me make it bigger for you. And the last one, there is a sample size. But we need one more. Who is that? The t-score, not the z-score. Absolutely, we are going to take the t-score from the t-table. Okay? So let me plug the one by one first. You know, the formula was x bar plus n minus. We are going to take the t-scores later. And now here's not sigma, but s, the sample standard deviation, and square root of the sample size, n. So the sample mean was 513.32 plus n minus. We are going to take the t-scores later. And the s was 262.23. 23, and then square root of 25. It's the same thing. It's almost the same thing. Instead of the sigma, but S, sample, standard deviation will be given. Okay, now I need the confidence level to take the t-score. It's the same thing. See? Here's a 95% again. I'm sorry, it's always a 95%, but yeah, that is a good confidence level. It's 95%. Okay, so let me go to the t-table. The t-table also has 2 pages. So let me show you the two tables. It's again, I mean together. But please look at this. It is a t-table. Here's the bell shape. It looks like the standard normal distribution, but it is not the z. It is a t distribution. And the very first one, there's a degree of freedom, df. What is a df? What did I say? Degree of freedom. We need a degree of freedom for the t-score. It is n minus 1. Who was the n? N was the sample size. How many sample size was in the example? 25, thank you. So the 25 is here at the bottom. Oh, I'm sorry. 25 is the n, but we have to do 1 minus. So the degree of freedom should be 24. 1 less, 24. But there are so many t-scores here. we have to choose one of them. Right? I told you we have 2 pages. It is the first page. It's up to the degree of freedom 49 here. And let me show you the second page. It's continuous, the t-table from 50 up to 2000. It's a 2000 here, right? And there is a last box here, but it said the Z, right? Let me make this bigger. Interesting. Who is this? It is a t-table. But at the bottom, on the second page, there is a z-scores. Can you remember 1.960? Who was that? Plus and minus 1.96. It was the z-score. What kind of confidence level? 95%. Just a second. Can you see this one? The probability there? 0.025. For 95% confidence level, where was the probability? 0.025. 0.025 was left tail. Do you remember you looked for 0.025 to get the z-score of 1.96? I mean the negative 1.96? Yes, they are. Just a second. Here's a 5%. Where? Left end. Left end 5%. Then how much will be the right end? 5% again, because the normal distribution is symmetrical. So left end 5%, right end 5%, together, how much? 10%. Then how much will be the probability in the middle? 90%. So now I can say 1.645 is the z-score for what kind of confidence level? 90% confidence level. You know, before, always we used the 1.96 only for the 95% confidence level. But now, here is another z-scores for another confidence levels. 1.645, it is the z-score for 90%. Let me try one more. 0.0005. It is a 0.5%. Where? Left end. 0.5%. Then how much will be the right end? 0.5%. Left end, right end, 0.5%, 0.5%. Yes, it is the 0.0005. 0.5%, 0.5%, together, how much? 1%. Then how much will be in the middle? 99%. I told you 95% is not the only one confidence level, but there are so many kinds, 80%, 70%, it doesn't matter, right? So here we have another z-score, 2.576, for whom? 99% confidence level. The same way, here's a 1% to the left. So 2.326, it is for 98% confidence level. And here's a 10%, 10%, 10%, 20%. How much will be the confidence level? 80%. Can you understand what I'm saying? It's good, right? Okay. They are the z-scores, okay, at the bottom. At the bottom of the t-table, there is a z-table. They're very simple. The z-table only for the confidence level. I make smaller, but you know, the very first one was the 80%, 90%, 95%, 98%, 99%. How many kinds of confidence levels? 5 kinds of confidence levels. How many columns in the t-table? 1, 2, 3, 4, and 5 again. They are the columns for the confidence levels. Can you understand what I'm saying? Okay, so now let me take the t-scores. Sample size was 25. So the degree of freedom was -1, 24. But there were 5 t-scores on the line, 24. We have to choose one of the column. How much was the confidence level? Confidence level was, again, 95%. Where is the 95% confidence level? In the middle. Column number 3. We are going to take the t-score on the middle, in the middle, the third column. So let me go back. Here. The degree of freedom was the 24. How much was the confidence level? 95%. Where was the 95%? In the middle. So we are going to take the score as a t-score. Let me make bigger. The t-score will be 2.064. You know, it's a totally different way. We took the z-score from the z-table. It's a totally differently. We can take the t-score from the t-table. From the degree of freedom, from the confidence level. So the t-score will be 2.064. So let me go back the problem here. The t-score was a 2.064. Okay, now give me the margin of error. Even now, we assumed we knew the sigma. The second part has the name, the margin of error. Yeah, please give me the margin of error, please. With the t-score, with the S, the sample standard deviation. At the beginning, the sample mean 513.32 plus and minus. What is the margin of error? Anybody? Don't forget, take the square root of the sample size. Please.
108.249.
108.249. You got it? Why don't you give me the interval form? Subtraction, addition. Take the smaller one, bigger one.
405.07.
And the bigger one?
621.57.
See here? Between these two. And here is the interpretation. What is the confidence interval? We can interpret we can 95% confident that let me add the unknown mean, the unknown population mean loss of all pickpocket defenses is somewhere between $405.07 and $621.57. It is interpretation. Confidence interval. How much confident? 95%. So the confidence interval is the interval estimation with the confidence. 95%. 90% sure. 99% sure. Right? Yeah, so that is the confidence interval.